A very simple chapter. See, first you should need to understand what is a permutation and what is a combination. So suppose if I take three numbers 1, 2 and 3. If I ask you make group of two numbers, okay, so what you can do, you can select numbers and make groups, correct? You can select numbers from the given numbers and you can make a grouping, okay? Suppose 1 comma 2, 1 comma 3, 2 comma 3, 3 comma 1, your wish. So since you are selecting numbers out of this and kind of just selecting and making groups, what are you doing? Selecting and making them groups in this way, okay? Just you are making, see, the requirement is to make group or pairs. So for making the pairs you need to just select the numbers. So you are just selecting, okay? So selection is also called as combination, because you are making combination of numbers, correct? Now see, here the ultimate objective is to make groups. We are making number of groups, correct? So these are the groups actually. So suppose 1, 2, 3. So I need to make two groups out of this, group A and group B. So group A and group B, if I want to make, I can make groups now. 1 comma 2 as one group, 1 comma 3 as one group, 2 comma 3 as one group, 2 comma 1 as one group. I can make one more group, 3 comma 1 as one group, 3 comma 2 as one group. So these are groups. I am making different groups. For making these groups, what I am doing, I am selecting numbers from these given numbers. That's called selection, and selection is called combination. Just selecting, just selecting, okay? Now second concept. Now how many groups you have made? Three groups here, okay? So three groups you have made by selecting the numbers from the given numbers. Now what is a permutation? That you need to understand. Suppose the second example, 1, 2, 3 are the numbers, okay? These are the given numbers. So we can make two-digit numbers out of this. So what are these two-digit numbers? What we can make? We can make 12, 23. We can make 12, and we can also arrange this in reverse order. That is 21, 32, okay, 13, 31, anything. So when you just take the numbers and you try to arrange them, okay, what are we doing here? Here we are not doing any kind of grouping. We are just picking the numbers and arranging them. So this is called arrangement, and this is called nothing but permutation. That is, selection and arrangement is permutation. Only selection is combination, okay? So now please write down these 2 points. Selection, you are selecting the numbers and arranging them. Selection and arrangement is permutation. Just selection is combination. Here you are selecting them and you are arranging. You are arranging one time as 12 and another time you are reversing it and making as 21. See, now you'll be having a doubt. Sir, you also did the same thing in the bracket. No, here we just selected and made a group. Here we are trying to arrange the numbers. If I have 123, if someone asks you three-digit numbers, 123, 321, 231, anything you can make. This is called permutation, okay? All of you write this. So I will just ask you a question. Just make a note of all this, then we will enter into the subject. So here you are just selecting, here you are selecting as well as you are arranging in different ways. Now I will explain you a question whereby you can easily find out the arrangement. Okay, so please see this question. See, now I am giving you numbers. Okay, 2, 6, what is this, 7. So these three numbers I am giving you, and I'm asking you possible arrangements of 2-digit numbers. What I'm asking you, how many 2-digit numbers you can make. Okay, so I'm giving you three numbers, 2, 6, 7, and I'm asking you 2-digit numbers. So how many arrangements we can do? 2, 6, 6, 2. This is okay. 6, 7, 7, 6. Correct. 2, 7, 7, 2. Can you make any other arrangement? Can you make any other arrangement apart from this? Please tell me, all of you, please. Hello? Hello?
No, sir.
Can you make any other arrangements? Is there any possibility? No.
No,
So
sir.
how many arrangements you can make?
6.
6. So the total, see, it's very clear, na? 2, 6, 26, 62. You can't make any other number. Then 27, 72. Then 67, 76. We already made. If I make 27, then I made 72. 67, 76. 26, 62. So all the arrangements I have done. So total permutations is equal to 6, is equal to number of arrangements. All of you just make a note of this. And if I ask you the same question, about combinations, then what will you do? So here is the next. 2, 6, 7, 3 numbers are given. How many groups I can make? 2, 6, 6, 2. Group number A. 2, 7, 7, 2. Group number B. 6, 7, 7, 6. Group number 3. So how many groups you are forming? Tell me.
Sir, 3.
3 groups. That's it. So what is the formula for permutation and what is the formula for combination? All of you, I will write the formula and we'll try to prove this point. So permutation formula is NPR. Okay, I will give you explanation. Don't worry. I will give you explanation and prove the point also. And combination formula is NCR. And I will write those formulas here. All of you make a note of this. My God, this is distracting a lot. So now if I say NPR, so how many numbers I gave you? Please tell me. 3 numbers, correct? 2, 6 and 7, and you made 6 arrangements out of it. That is 6 permutations. How you can find out that one? How you can do that permutations? Yes. What is the formula? NPR. Okay. So there are 3 digits. So we can make, actually here we are not, there is nothing like how many, like we have this 3 numbers and we have made like 6 arrangements out of it, correct? So I can write this as 3 factorial, that is 3 into 2 into 1, that is 6 arrangements, correct? All of you make a note of this. And how you got this 3 factorial? I will prove this. So this is NPR. So n factorial by n minus r factorial. Okay. So first of all, what is a factorial? That is also kind of troubling you. See, factorial means, suppose I say 7 factorial. What is the meaning of 7 factorial? 7 factorial can be written as 7 into 6 into 5 into 4 into 3 into 2 into 1. This is 7 factorial. So if it is 3p3, so I have 3 numbers, okay, and I can use those 3 numbers, correct, for my arrangements. So see here, oh sorry, it is 3p2 now. I have to make 2 digit numbers, correct? All of you please tell me yes or no.
Yes, sir.
Yes, sir.
So I am making how many arrangements? 3 factorial by 3 minus 2. Yeah. So now you see, all of you, it is out of 3 numbers I need to make how many digit numbers? See, I am given how many numbers? 2, 6, 7. How many digit numbers I need to make? How
Two.
many digit numbers I need to make? What is this number? 2
Two.
digit numbers, correct? So how many arrangements we saw? 6 arrangements. Now we will prove that. 3 factorial by 3 minus, what is r? All of you
Two.
tell me what is r. This is n. N is always greater than r. R is
Two.
this 2. So 3 minus 2
Two factor.
factorial. So please tell me 3 factorial by 1 factorial is how much? 3 factorial.
Three
Can I write
factor.
3 factorial as 3 into 2 is equal to 6? All of you?
Yes, sir.
Yes, please make a note of this. So now we have proved the point with the formula also for permutation. Now let us prove the point for combination. So this is the permutation formula. I will give you a derivation of this. Okay, please understand the derivation, all of you, very properly. What is exactly happening here? So theorem 1. So theorem 1, permutation, that is arrangement of r out of n different things. So here we had three numbers 2, 6, 7, and we want to arrange how many digit numbers? 2-digit numbers from these three given numbers. So we arranged and we got 6 as the answer. 6 arrangements can be done. That theorem, that how you are doing, I am proving with the help of a theorem. So permutation of R out of n different things. That means arrangement of 2-digit numbers out of 3 numbers. How will you do? See, the formula is NPR. This is the way with which you can do this kind of arrangement. That is R digits out of n given numbers. So 2 digits out of 3 given numbers. Okay. So that also you can understand with this theorem. Let me give you the concept. So here I have n different things. I'll do it neatly just a second. N different things, and always n is greater than r. That is the rule. Okay. Now are different things taken at a time for each arrangement. So what you will get? Total number of such arrangements. So given is n, out of that you are arranging how many digit? 2 digit in our example. So r different things. So you have n different things and you need to take r different things at a time for each arrangement. R different things. So 2 out of 3 numbers you are arranging 2 numbers, correct? Out of 3 numbers given you are arranging and making 2 digit numbers. So let's say here n different things and here there are r blank spaces. Okay, so what you will get? So now if you have I will show you this particular example. I'll give you a very good example. Just a second. So total number of ways, one more example I will give. Of filling R blank spaces with n things. So you know in our example we had n things, that is 3 numbers 2, 6, 7. And how many digit numbers we were supposed to make? 2 digit numbers. How many spaces we had? 2 spaces. Correct or wrong? All of you please tell me. Hello.
Yes, sir.
So you had n different things and you had how many spaces? R spaces,
Uh,
2 spaces. So how many numbers you can make? How many arrangements you can make? 2, 6, 6, 2. 2, 7, 7, 2. 6, 7, 7, 6. Can you make any other can you make any other arrangement out of this? Please
No,
tell me.
no, sir.
So how many arrangements you made?
6.
So that's the same thing you are doing now, n different thing in r different spaces, correct? Now,
Yes, sir.
so if we do, see, we cannot do every question in this long procedure. So in order to save your time, they have given a very good formula for permutation. Instead of doing this practical, instead of using this practical approach, you can directly do that with the help of this formula NPR. So in your exam, don't go for any practical solving, go for direct formula. If they ask you that they have given you so and so n different things and you need to arrange them in R spaces, you can do that in NPR ways. Okay. Now, so here n is always greater than r. So r blank spaces, all of you make a note of all this, can be filled with n given things. So nothing you should repeat in this arrangement. Okay, the arrangement should be made in such a way that no repetition should happen. I'm writing that point also. Lot of nothing should be repeated in any अरेंजमेंट. अरे वो उसको कॉल करो ना, इट मैथ वाले को, इट मैथ. Number of choices available, n different things. That means they gave you three numbers. Okay, these are the choices and you have to make 2-digit numbers. So all of you, everyone, you number of choices, p spaces to fill. Okay, so all of you understood this concept now. Now I will give you a question and all of you give me the answer of that question, please. See, permutation combination is not a tough chapter. Direct formulas you can use. But what has happened is many of the students are scared of this chapter and they don't learn it properly. That's the reason they commit blunders. Okay, and they are scared of. Now take the question. That means I gave you this particular formula, and this formula is only applicable when n given things, nothing should be repeated. That means if the problem is given you for without repetition, use this above formula NPR. Okay, so you cannot repeat the digits again and again. So please tell me what is the solution or answer for this. Come on, all of you, please solve this. Okay, please tell me. Come on, I don't know what the time you take, and also answer is 6p3, correct? That is
Yes,
NPR.
sir.
You have how many digits? 1, 2, 3, 4, 5,
6.
6. You have n options available with you, that is 6 options, 6 numbers are given, and how many blank spaces? 1 2 3 blank spaces, that is r blank spaces. How many numbers you can make? Find out and tell me.
3.
6p3.
6
So
into
you
5.
cannot do na 7 3 5 and all this you cannot do manually, so directly apply the formula and tell me. No one is giving answer. I don't know, are you people sleeping
90.
or doing the questions? 6
120, sir.
factorial. Yeah.
120.
Yes, 120. Very good. Who gave the answer? Hashita
Sir.
or Jeevana? Who is this?
Hasita, sir.
Ah, good, Amma, good. Yes, 120 is the answer. 6 factorial by 6 minus 3 factorial. So 6 into 5 into 4 into like 3 factorial by 3 factorial. Cancel 30, 34s are 120. So 120 ways. All of you do this. We'll go for the next topic. Now, so now the theorem number 2. See, theorem 2, permutation of n different things and in this case the what is coming into picture is some alike and some different. Now, how to do this permutation? Please understand. Now, see, number of permutations, number of different permutations of n things taking all at a time when p of them are similar of one type. It's a very simple theorem. I will tell you with the help of a question. Q of them are similar of another type, and the remaining n minus p plus q are all different is given by the formula, direct formula you have to use. So there are n different things. Suppose you have 10 numbers. In that p and q are similar. P is similar of one type, q is similar of one type. So n minus p plus q is just removing the similar type numbers. You have different numbers only. If you remove similar type numbers out of the total given numbers, you have all different numbers, correct? Now, how to do the permutation of this? Formula is n factorial by P factorial into Q factorial. All of you make a note of this. Don't worry, it's a simple one. I will explain you with the help of a question. So here numerator has what? The permutation of all the things. And denominator has what? Permutation of alike things. Wherever you see this factorial thing, it's kind of arrangement only. Now, let's take a question. All of you please try to solve this. Find the number of different words that can be formed from the word success. Come on, do this. Yes, tell me the answer. Yes, कहाँ पर हो? Yes, yes.
Sir, doing.
Okay, fine. Okay. 'Yes, it is not only yes, anyone can answer the question who has done first. Formula is already given to you. Now I don't know for what you are waiting. N factorial by P factorial into Q factorial. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7. So 7 factorial divided by how many alike terms are there? C is there 1, 2, 2 times, and S is there 1, 2, 3, 3 times. So 2 factorial into 3 factorial. Come on, tell me the answer. Solve this.
420, sir.
Yes, 420. Good. Twenty, 23s are 60, 67s are 420. All of you write this. अरे उसका फोन है बात कर. Okay, now let's go for the next question. Next theorem, all of you. Permutation of n different things all at a time. So suppose if I give you I will tell you just a second. First write the theorem, we'll do the question. So now the number of permutations of n different things taking all n things at a time is n factorial. For example, you have three numbers 2, 6, 7. In our example, we did what? We wanted to make two-digit numbers out of three numbers, correct? Given three numbers. So we did 3p2. What if I say you have to make three-digit numbers out of this? So the formula would be 3p3, correct or wrong? Three numbers out of three numbers. That means three blank spaces out of three available numbers. 2, 6, 7. Correct or wrong? All of you tell me. N is 3, R is 3. Correct? So how many numbers I can make? 267. Let us see how many ways. So you have to take all of them at a time. Okay? All the three numbers you have to arrange in three spaces. It's not like you need to arrange, you need to make two-digit numbers out of three numbers given. Three-digit numbers out of three numbers. So 267. Then what we can do? 276. Tell me how many ways you can do, please. Tell me what shall I write?
672.
Yes.
627.
267 is done. 276 is done.
630.
627. 672.
72.
Yeah. And again then
726.
726. 762.
760. 70.
any other arrangement?
No, sir.
Any other ways? Please tell me.
No, sir.
Uh, we have taken all the ways available. So it is how many ways we did?
6 ways.
So if I say 3p3, let us find 3 factorial by 3 minus 3 factorial. 0 factorial is what? Correct.
1.
0 factorial is what?
1, sir.
3 factorial is
3 into 2 into 1.
finished. So now for all this, need not go for this 3p3 and all. Directly n factorial. So 3 factorial is what?
6.
6 ways, correct? So directly n factorial. If you are taking all the numbers at a time. Now, please do this question. यश क्या हुआ यश बिल्कुल भी बोल रहे नहीं कुछ
आई एम देयर सर आई एम देयर
फोकस कर रहे हैं ओके
हाँ सर
एक ये बहुत परेशान करता है मेरे को Come on, tell me. Yes, you do. I'm coming in a second. Yes. What is the formula? What is the answer? What, man? You're not answering any answers. Why like that?
720, sir.
No.
Seven 20, sir.
Huh?
720.
No. Very simple. How many numbers? 1, 2, 3, 4, 5, 6. 6 factorial ways. N factorial. Correct? 6 into 5 into 4 into 3 into 2 into 1. Maybe. Let us check. 6 fives are 30. 34s are 120. 123s are 360. 362s are 720. Answer is 720. All of you got?
Yes, sir.
Yes, sir.
All of you got 720? Yeah. Yeah, it is correct. Yes, yes, yes. Now, so here we have taken all 6 letters at a time. Okay. Now, I am giving you another concept, permutation with repetition. Now, so here you can repeat the numbers. Okay. So number of, see, very simply you should use the formula. Okay. Permutation of n different things taken r at a time when each thing may be repeated any number of times. See, you can repeat. Actually, if at all you have 267, so you can make what numbers? 267, you can make 260. You can repeat the numbers like 277, 266, like that also. Two times also you can take. Got my point, all of you? Hello? All of you?
Yes, sir.
Yes, sir. Yes, sir.
Yeah, yeah. You can repeat the numbers 222, 277, 266, like that also. So number of permutation of n different things. See, you should not go for all the mechanics. Directly apply the formula which I'm giving. That's it. That's simple. So number of permutation of n different things taken are at a time when each thing may be repeated any number of times in each arrangement is n power r. So n different things and number of permutation of n different things taken are at a time, and each thing may be repeated, so that you can arrange such in such cases you can arrange in n power r ways. Okay, so here we have n different things, and then you have r things taken at a time, each of the n things may be repeated once, twice. That means you can repeat them and once, twice, up to r times. That means here 3-digit number if you are making only, you if I have 222 I can make. Okay, in any arrangement. So total number of such arrangements is n power r. All of you make a note of this. So here we have n different things. And here we have r blank spaces. So now here each blank, each of blank spaces can be filled with any of the n given things. Since repetition is allowed, so each blank space can be filled in n ways. So you can fill each blank space in n ways. Suppose you have 6 numbers. So you can take 6 numbers, you can take each number here, correct? So how many numbers are there? 6 numbers. And how many blank spaces you can see? 1, 2, 3, 4, 5, 6. 6 power 6 times. That means each blank space can be filled with any of n given things. So I can fill this particular column with 6 numbers. This particular column with 6 numbers. This particular column with 6 numbers. Okay. So now take this question and tell me the answer of this. Come on, do this. Yes. So see, in a wedding ceremony, a person has how many friends? You know, n is always greater than r, correct? How many friends are there? 7 friends, correct?
Yes, sir.
So 7 friends are there, and how many ways can he send invitation cards to them if he has 4 servants to carry the cards and to deliver the same? Hmm. So we can take 7 friends here. So here I have not given any condition n greater than r or something like that. Okay. So here who is repeating? Like servants will be going to each house now. How many friends are there? Here nothing is like n is greater than r. Okay. You should understand the concept. How many friends are there? Please tell me. 7 friends. In how many ways can he send invitation card to them if he has 4 servants? See, the first servant can come to this house. Please tell me yes or no. Hello.
Yes, sir.
First servant can come to this house. Second servant can also come to this house. Third servant can also come to this house. Fourth servant can also come to this house. So how many servants can come to this house? Correct. So how many ways the card can be sent to the first friend? Correct or wrong? Please tell me. 4 ways. See, 4 ways the card can be sent here. So this friend also 4 ways. This friend 4 ways. 4 ways. 4 ways. 4 ways. 4 ways. So what is the formula I gave you? N power R. So who is repeating here all the times? And R is nothing but how many spaces are there? So now can I say repeating thing whole power non-repeatable friends? Why non-repeatable friends? Because card can only go to one friend at a time, but four servants. See, there is A, B, C, D. So servant 1 can also go, 2 can also go, 3 can also go, 4 can also go. So in 4 ways, the cards can be sent. But the card would be sent to only one of the friends. So this is flat number 201. So 201 flat number friend can get card from any of the 4 servants. Correct or wrong? Please tell me yes or no.
Yes, sir.
So A, B, C, D are the 4 servants, and 201 flat number can get the card from any of the 4 servants. Any of them can go. I'm not saying all of them will go and give 4 cards. What will he do with 4 cards? He will accept from any one of them, but anyone can go, na? Same is the case with 202 flat, 203 flat, like that. So 4 power 7 ways. Okay. Please make a note of this question fast. We'll go for the next. You make a note of that. I'm just writing something. So now please understand this, and I'll write the steps. See, if there are two different groups of persons, like suppose there are boys and girls, these are two different groups. First group of n persons, that is suppose there are 5 boys, and second group of m persons, and I already told n is greater than equal to m. So 4 girls. So there are 5 boys and there are 4 girls. And all of these persons are to sit in a row. Yeah, they can sit in a row, of course, with the condition that no two persons of the second group, that means two girls should not sit together. That means there should be a boy between two girls, correct? So now you should see the sitting arrangement, how that can be done. So we will see how to do, and I'll give you a question. See, the number of boys can arrange themselves in n factorial ways. Already told you, if all the boys are taken at one time, they can, see, you can arrange the boys in n factorial ways, now all taken at a time. So now in between n persons, there are n plus 1 blank spaces. Of course. So therefore, I will tell you how. Therefore, number of arrangements. For example, there are 5 boys. So how many blank spaces are there? 1, 2, 3, 4, 5, 6. So there are 6 blank spaces. So n plus 1 blank spaces, correct? 5 plus 1. So number of arrangements of m persons of second group in the n plus 1 blank spaces is equal to n plus 1 pm. That means 5 boys plus 1, that is 6 blank spaces. P number of girls are 5. Okay, so in this ways. Now I think there are 4 girls, correct? Yeah. So boys, so all the boys can be arranging themselves in 5 factorial. So 5 factorial into 6p4 ways. That is the answer. I think there are 5 boys I took, yeah, according to my question. So now I am giving you the same kind of conceptual question. Solve it and give it to me. Solve it fast. बस एक थ्योरम और हो गया, कॉम्बिनेशन बाद में ले लो, कॉम्बिनेशन बाद में करेंगे, परम्यूटेशन तो होगा. Yes, Yash. Yes, answer. 6 boys can arrange
Sir,
themselves in how many ways? 6 factorial.
is
See, I'm
answer
making
very
one,
sir is
2,
sir
3, yeah, 4, 5, 6 boys. 1, 2, 3, 4, 5, 6, 7. 7 blank spaces. So 7p. How many girls are there? 4 girls. Okay. And boys can arrange themselves in how many ways? 6 factorial ways. 6 factorial into 7p4. All of you make a note of this.
sir is answer very big na sir.
Don't solve it. It will be a lengthy answer.
It's lengthy only sir.
Yeah. So you can arrange this. You can arrange 4 girls in this 7 blank spaces in 7p4 ways. Okay. Last concept. See, I am finishing permutation. Combination I'll try to take in the evening or else in the afternoon after 1 or 1.5 hours. So I'll give you the worksheet to solve the questions. Okay. Himani. Number of different permutations of n different things arranged around a circle is n minus 1 factorial. So number of different permutations of n different things arranged around a circle. So when there is a circular arrangement, it is n minus 1 factorial ways. This is the direct formula. Direct formula. Now, in this a small concept. So here clockwise, see, either you can arrange in this way clockwise or you can arrange in anti-clockwise way. So here clockwise and anti-clockwise arrangements have been, that means you can arrange in any ways, considered as different arrangement. However, if the clockwise and anti-clockwise arrangements are not considered different, number of circular arrangements of n different things is equal to 1 by 2 n minus 1 factorial or n minus 1 factorial by 2. All of you make a note of this. See, I'll give a question. I'm running out of time. After an hour, I'll try to take one more small session, but right now I'm running out of time, so please take the question. In how many ways 6 delegates can be arranged in a circular table? So the answer is 6 minus 1 factorial. Come on, all of you do this. 5 factorial. So now some more questions are there. It's not done. We will do combination 3 theorems. We will do combination 3 theorems and some more after some time. Okay. So right now, all of you have done. We'll take the class in the afternoon again. Please go to this recording once again. Okay. Thank you, all of you.
Thank you, sir.
Thank you, dear. Thank you. Thank you.